All right. Can everyone hear me? It looks like it's going pretty well. Good morning, everyone. My name is Richard Dwayne Chambers, and I have the pleasure of leading Senator Cantwell's team on all things, or almost all things, science, space, and semiconductors. And beyond that, it is my pleasure to welcome all of you to this Washington Space State Summit. Over the next hour, you can look forward to hearing from our panel of leaders in business, in research, and in education on the importance of growing the space sector in Washington State and what actions we can all take to make sure it continues to thrive. We'll hear opening remarks from Senator Cantwell and from NASA Administrator Bill Nelson, followed by short 2-minute introductions from each member of the panel. And I apologize in advance to the panelists that I'm going to try to watch that time like a hawk. You'll see me waving at you. And the only reason is I want to hear more from you, but I also want to make sure that we have time to do a round of questions from myself, from Senator Cantwell, from Administrator Nelson, and also from members of the audience. And as a quick programming note, we will ask members of the press and the media to hold their questions here. We'll have a separate opportunity for questions directly after this. So please settle in for about 75 minutes, I said 60 before, 75 minutes of what I hope will be a really engaging and informative discussion on building the future right here in Washington. So with that, I'll turn it over to Senator Cantwell to open the event with her remarks.
Well, thank you, Richard Dwayne. Wow, this is what happens when you're in a space tech facility. All the technology works. This is great. You don't have to worry. They did all the dry runs. Well, first of all, thank you to Bob Smith, the CEO of Blue Origin, for hosting us here today. Thank you for that. And thank you to everybody for participating in the showing of what is great technology here in Washington. I want to welcome NASA Administrator Bill Nelson to this part of Washington and to thank him for not only his leadership at NASA, but his continued focus in making sure that our country maintains our leadership. We're here today to discuss how our state and our country stays ahead in space. Just over 11 years ago, the Seattle Times published an article with a headline that said, quote, "What would it take to become the Silicon Valley of space?" The Puget Sound area already had been known for leadership in aviation, but it was probably the first time a major newspaper associated the phrase, quote, "Silicon Valley of space" with Seattle, and asked how Seattle could become a leader in space innovation and entrepreneurship. The author, just so you know, it's not Dominic, okay. But anyway, the author had two major concerns. The Seattle faced tough competition from communities across the United States, and that American leadership in space overall was drifting. What a difference, though, 11 years makes. And we can see here today that many companies in the state of Washington are providing growth and opportunity for space jobs. It's providing a booming economy, and it has helped maintain America's position in leadership of space exploration. So I want to thank everybody for that. Our more than 100 space companies are innovating in the satellite manufacturing, design of new rockets, solving everyday problems from the moon to Mars, and that innovation will also help us with aerospace in general. The facts are clear. Our space cluster is growing fast. In 2022, the Puget Sound region released a report that showed Washington's space industry had more than doubled in 4 years to $4.6 billion and had over 13,000 jobs. These workers are going to help NASA's Artemis mission deliver. And we are going to send the first woman to the moon, and we're going to get to Mars. Again, I want to thank Administrator Nelson for coming to see all of this, to see Blue Origin, Aerojet, Rocketdyne, Boeing, and many other of the Artemis contributors. Blue Origin's lunar lander alone will generate more than 1,000 jobs, and more than 40% of the satellites directly above our planet are made right here in Washington as well. And companies like SpaceX and Amazon's Kuiper, who we just saw a demonstration from, these satellite companies plan to increase production to more than 50 satellites a week and high-speed broadband connectivity around the globe. So these investments in new materials and manufacturing will help us produce more aircraft, train new people at our universities and technical colleges, and continue to make investments. So even though there are 1,000 current openings for space jobs right here in Washington State, these are jobs from software developers to engineers to welders to machinists, and some of those jobs average over $100,000 a year and don't require a 4-year degree. So the question is, what do we need to do to continue to make ourselves more competitive? From machining to material science, we must increase and support manufacturing technologies like high-rate composite manufacturing and train and skill the technical workers to fill these jobs so that people can continue to help us meet this competition from a national level. Today's jobs and tomorrow's futures jobs are going to depend on the manufacturing sector assembled here today. And that is why I encourage the Department of Commerce and NASA to create a new manufacturing institute here in the Pacific Northwest. I was happy to hear NASA Administrator say in May he's been working on that recommendation, that he has been working with the executive branch on that concept, and to make sure that we stay competitive in the next generation thermoplastics high-rate composites. I will obviously be asking the panelists more about this and how our universities and community colleges can work together, and places like Snow Isle Technical Training and Gravitas, Starfish, all these people who are creating new jobs, what we can do to get the workforce. When we put the CHIPS and Science Act together, we also made a $250 billion investment into STEM education. I'm hoping this education can be used to educate and train people in this area, and that it will help us complete our Mars mission. So I, again, hope that we can talk to people today about these innovations, about the workforce of tomorrow, and how we can help the supply chain by not only just building for aerospace, but building for space too. Thank you very, very much. And let me thank my staff for putting on a fabulous program today, and everybody for participating.
Administrator Nelson.
Well, good morning, everybody. Thank you for your hospitality. Thank you for what you've done, the hard work here in setting up all these exhibits. Maria and I visited each one, and I've learned a lot. So thank you very, very much. You need to know that Maria and I sat next to each other for 2 decades on the Commerce Committee. She used to tell me what to do then, and she still tells me what to do now. So when she said, we're going to have this manufacturing institute, I said, yes, ma'am. It's needed. It's needed with the global competition that's going on. It's needed that we take our ingenuity as Americans, our creativity, and we apply this to the things that we need to be better at. And it is one of those institutes that would certainly benefit our country, and ultimately in the development of technology, it'll benefit the world. It'll specifically also benefit the state of Washington. Now, you take, Maria said a little over a decade ago, what a difference a decade and a half make. The two of us had the privilege of having something to do with that because of the landmark NASA authorization bill. Also, a Texas Republican Senator, Kay Bailey Hutchinson, who, by the way, I now have on the NASA Advisory Council. And we passed the blueprint, the roadmap for where NASA was going in the future, and you're seeing the results of that as evidenced right here in these exhibits today. Because we said going forward, NASA was going to bring commercial partners. We were going to have a substantial increase in a grant program with industry and with academia, and that as we go forward, and since we're going back to the moon after a half a century, we're not going back just to go. We're going in order to learn, to live, to work, to invent, to create, in order to go to Mars and beyond. And so we do so now with commercial partners. Blue Origin is a good example, along with SpaceX. They're developing the 2 landers for us. We're going to take them, the crew, in our Orion spacecraft on the big rocket that we've already had the test flight on, and it was just extraordinarily successful. We're going to go into lunar orbit, and then they're going to transfer into the initial flights. Will be 2 of the crew of 4 will transfer into the lander, and that will be the first woman and the next man that will walk on the surface of the moon. And this will go on for years and years. So it's a commercial partnership. Remember, last time we went to the moon, it was U.S. government. This time, it's a commercial partnership. It's also an international partnership. You will see that NASA is a hot commodity in the nations around the globe because these countries' governments want to work with us. And so for our United States foreign policy, NASA has become quite an instrument of soft power in our foreign policy. The first flight to the moon will be next year. 4 astronauts, 3 Americans and a Canadian. I'm dressed like this, save for my jeans, which Maria told me I couldn't wear jeans here today, because tomorrow I'm going to the biggest rodeo in the world, Calgary, Alberta, the Stampede, and I'm joining the Canadian astronaut that's going to the moon. He's going to be the Grand Marshal of the Stampede Parade. And this is the excitement of the future that we have going forward. It's the excitement of all these exhibits here also. It's the excitement of what the universities and the community colleges, and I said to the community colleges, crank them out, because a lot of these startup industries can't get enough employees. And then they have to compete with the big boys on wage scales. All of this is happening right here in the state of Washington. There are 4,622 jobs as a result in Washington of the economic impact resulting from NASA contracts in the state of Washington worth $427 million. That's right now. And according to Citi, the commercial space industry is on its way worldwide, reaching $1 trillion in annual revenue by 2040. So that's where we're going. So you all are at the cusp of this, and it's happening in front of our very eyes. And I might say that thanks to the quality of your leadership, and by the way, I want to welcome the mayor and also the president of the city council because of the quality of your leadership, your governor, Jay Inslee, the senior senator, Patty Murray, and especially Maria, as she works on these issues. The proof's in the pudding. And the proof is right here. So thank you all for having me.
Thank you very much. Thank you very much, Administrator Nelson. And with that, I'd like to turn it over to our panelists. So we are going to ping pong a little bit around the table today, but I'd like to start off with some of our industry representatives to speak about the work that they're doing here in Washington. So I'll start off, I'll turn it over to our gracious host, CEO Bob Smith of Blue Origin.
Good morning. How's everybody today? Welcome to Blue. So glad to have you here. It's a great day to be a host to Senator Cantwell and Senator Nelson. We are very honored to have you here. But I think one of the things that I love about this particular event is that it's representative of what we do. So there's almost a drinking game about how we talk about our vision all the time, right? Which is 1 million people living and working in space for the benefit of Earth. We say that all the time. The reason why we say it because it reminds us what our North Star is. It reminds us what we're trying to go do, which is trying to get the entire of humanity into space so that we can relieve what we're doing to this planet. And it's incredibly important to us. But the reason why it's so important to us to have these type of events, because it's also representative of what we're trying to go do overall, which is we don't want to do this in the same way that's been done before. We want to bring everyone into space. We want this to be a very diverse workforce. We want it to be an inclusive one where everybody feels that they're here. So as we've grown over the past 5 years from an 800-person workforce when I joined to now over 10,000 people, we've kept that first and foremost. People with different backgrounds, different skills, different overall capabilities around that. So that's point one. That's why this is important. Secondly, it's why we actually talk about another generation. That's why we have Club for the Future. Some of you may have seen the display here where we talk about Club for the Future, because we know this vision is so bold and so grand that it's going to take more than one generation to do this. It's going to be our children and our grandchildren that are actually going to see this happen. And that's why we spend, and every employee at Blue Origin is an ambassador for Club for the Future. And we say, this is part of your job. This is part of who we are, is for you to promote another generation. And then we love this type of event. When this was proposed by Senator Cantwell, we're like, yes, of course we're in. We want an aerospace summit for Washington because we know it's going to take lots of companies. We're rooting for everybody to succeed because it's going to take lots of companies, not just Blue Origin, but we want all the companies to do this. We want it to be done well around the globe, but particularly here in the United States, so we can maintain that competitiveness. And also, we found such a great state for us to have our headquarters in because we get the kind of support that we need. Because one thing I always like to remind people is that great government actually begets great business. It doesn't work the other way. The only way that you actually have great commerce, you have great societies, you have a dynamic, innovative society, is if you have great government. If you want to look at counterexamples, look at Russia. It's a kleptocracy. You can look at other places where there's incredibly corrupt practices in all their commerce. But we have the great benefit of great courts, great governments, great senators, great administrators that all allow commerce and innovation to happen. And that's why we're so excited to have this. And that's the only thing I will continue to say about Washington is just never forget that we're always in a race. This is always a competition around the world. And we have to out-innovate and make sure that government and industry work together to do all that. So I won't be any more long-winded than that, but say thank you and welcome. So glad you could all be here. Thanks.
All right. Thank you so much. Now I'll turn over the next 2 minutes to Andy Lapsa, CEO of Stokes Space.
Well, first of all, thank you, Senator Cantwell and Administrator Nelson, and thank you, Bob and Blue Origin, for hosting this event. It's an amazing time to be part of our industry. It's truly a renaissance period. But I also want to think holistically about our place in history. It's really just the very beginning for our industry to take off. If you think about us and where we are in the context of other forms of mobility and commerce, we're remarkably primitive. Our ability to send things from Earth to orbit, move things around orbit, and bring them back down is incredibly slow, it's incredibly expensive, and frankly, it's unreliable. So, by comparison, we can ship anything from here to just about anywhere in the world in 2 days. Right? We can't even think about doing something close to that for space. So it is truly the very beginning for our industry, and that's what makes this moment so important and so exciting. We think about that, again, from a holistic perspective constantly at our company, Stoke. We think about how companies can get their products from factory to revenue as fast as possible, no matter where they need to go on orbit. We think about moving them around orbit and bringing them softly back on the Earth, or frankly, any other planetary body. That's what we set out to solve as a company. We built 100% reusable rockets designed to fly daily. We've focused our early energy on solving the reusable second stage space vehicle problem. I personally think that that's the last big domino in our industry to fall in order to unlock the true capability of space commerce. And so that's where we focused early on. Our vehicle, the whole stack, has meaningful capacity to any orbit, has meaningful capacity to other planetary bodies, and has the ability to bring those things back down to Earth. Since we've founded, we've received over $100 million in financing. Virtually 100% of that financing stays right here in Washington State. We operate about 175,000 square feet of engineering and manufacturing space. We have built, in the last couple years, a state-of-the-art rocket engine test facility in Moses Lake, about 3 hours east of here. And we're very excited to continue to build our workforce. As a company, we've gone from seed funding to full-scale rocket engine testing faster than any company has ever done it. We've now fully demonstrated our very important piece of our tech stack, which is a fully reusable heat shield, which is integrated into our vehicle and can turn around very quickly. Importantly, it eliminates the need for very fragile ceramic tile thermal protection, such as what was used on the space shuttle. So this is one of our very key technical innovations. We've also become one of the only 6 companies in the US joining Blue Origin to operate a launch complex down in Cape Canaveral. We have dedicated use of Launch Complex 14 down in Cape Canaveral. And so we'll continue to scale, obviously, our engineering and our manufacturing and our testing here as we build down in Cape Canaveral. So again, thank you for hosting the event. It's wonderful to be here and look forward to the discussion.
All right, thank you so much. The next 2 minutes to Austin Link, co-founder of Starfish Space.
Thank you, Richard Dwayne. Hello, everybody. I'm Austin, and I'm one of 2 co-founders of a company called Starfish Space. And before that, I worked here at Blue Origin, so this is really exciting to be back today. I have my blue socks on, which doesn't work because nobody can see them. But I want to say thank you to Blue Origin for hosting and for long ago hiring me once. At Starfish Space, we are building a satellite that we call the Otter. It's designed to grab and move other objects in space. This is really initially useful for 2 missions that we focus on. One is to help extend the life of large satellites so they can continue to operate and provide value. And the other is to dispose of space debris, specifically dead satellites, in particular in low Earth orbit. We are really on the leading edge. As Andy talked about, this is the early days for us as an industry. We're on the leading edges of seeing a new wave of satellites in orbit. And thousands of satellites are being launched a year, and that changes space from a realm that was kind of open and space debris from a problem that maybe made a good Sandra Bullock movie to one that's really threatening billions of dollars in infrastructure that we're putting up on orbit. And so we see our role as Starfish to help dispose of satellites at the end of their life and ensure that we can continue to use space to provide value to folks back here on Earth. We are in still relatively early stages of doing that. We as a company have about 40 folks. We've raised $23 million in venture capital. We have contracts with NASA, the Air Force, the Space Force, Defense Innovation Unit. We are all located just up the road in Tukwila, so we can walk to the South Center Mall for lunch. We, as of 3 weeks ago, just launched our first satellite to orbit, which we call the Otter Pup. And it's designed to go up there and at least attempt to dock with another satellite on orbit. Now, it's been a bit of an adventure so far, which keeps things fun. That's part of the space industry. You get tremendously challenging problems, and you get to try to tackle them. And what I'm really excited about with the Otter Pup, with the Otter, and what goes beyond that is it's a potential not just for immediate missions, but if you can reliably and regularly go up to another object in space and interact with it, it creates an entirely new dynamic way to do missions in space. And someday we'll be launching up the next version of the James Webb Space Telescope, and it won't be $8 billion with 300 single-point failures folded into a single launch vehicle. We'll send it up in 100 different parts, and it will be bigger and better and more affordable and more reliable than we could ever do. And that's going to start with the ability to interact with these objects and put them together and dock with them. And how am I getting a phone call right now? That's wonderful.
They're telling you it's time.
Oh, that's you. You're telling me my 2 minutes are up. That's sneaky, Richard Dwayne. Well, with that, I'll say thank you to everybody again for being here, for listening to me waste 2 minutes, and I'll turn it back to you.
That's time well spent. Thank you so much. All right, next we'll hear from Colin Dawn, CEO of Gravitics. Your 2 minutes.
Hello, everyone. Thank you so much. Gravitics, we are building large spaces for space, large volumes. You know, to hear Administrator Nelson, you talk about that vision for space, the part that gets everyone excited is that Canadian astronaut, the first woman landing on the moon. It's the people. And Gravitics believes in extending human flourishing throughout the entire solar system. Large volumes, built like Lego bricks to make it easy for space stations to scale as commercial interest requires it, is really what we're all about. And we are located just north of Seattle in Marysville. We've got 50 people there, and Washington has been absolutely fabulous for us. That vision 10 years ago in the making was absolutely the reason we came. The workforce is here, the innovation is here. We are excited about onshoring that manufacturing capability that right now largely lives in Europe and in Italy, right here in the US, so that that next wave of human-inspired excitement for space development happens right here in the US. So we are excited to be a part of this panel, excited to be a part of this next wave of commercialization. And we see Washington and the US as that innovator that is going to open up the final frontier for all of humanity. Thank you.
So I believe we heard in Senator Cantwell's opening remarks that Washington is solving every problem from here to the moon. And I think we just heard, we're landing people on the moon, we're making our rockets reusable, we're cleaning up space, and we're bringing back manufacturing. So I think it was a great thing to hear from our industry partners. I'd like to turn it over now to some of our educators, and we'll start off with Dean Jihui Yang from University of Washington.
Yeah, thank you very much. I'm extremely proud to be here. University of Washington has been in the space community for a long time. So our first priority is workforce education. I agree with the theme of it's about people. We're a proud home for NASA's space grant, which the role is to promote opportunity for students who are interested in the space industry. And about 2 years ago, we have allocated additional faculty lines, cluster hiring faculty lines in the area of space engineering and system. We're being a long member of research community in the state of Washington. For example, we are the home for FAA. I think Senator Cantwell was a champion for this. About 2 decades ago, we are the home for FAA's Center of Excellence for Advanced Materials in Transport Aircraft Structures. We're also managing the Washington Joint Center for Advanced Space Innovation. And we also have materials research centers for advanced composite. We have been working with many industry partners, including Boeing. We have a Boeing Advanced Research Center at the University of Washington. So we're committed to continue to work with this community, both in terms of future workforce education and research, to develop the technology, to produce the workforce necessary for us to go to the moon, the Mars, and beyond. So thank you all very much.
Thank you, Jihui. I'll now recognize Dean Mary Rizak from Washington State University.
Good morning. I'm Mary Rizak, Dean of the Voiland College of Engineering and Architecture at Washington State University. My college produces more than 1,200 new STEM graduates annually, contributing to every sector of the Washington economy. Blue Origin alone has hired hundreds of WSU graduates in the past decade, and we've had the opportunity to meet with several of them this morning, so go Cougs. While our numbers have grown dramatically since the Great Recession, we recognize that our workforce efforts are insufficient to meet demand. The Washington Roundtable estimates that less than 50% of the new STEM jobs in the state could be filled by in-state graduates. Furthermore, with expansions in the space industry, microelectronics, and other sectors, we expect to see tens of thousands of new STEM jobs here in Washington in the next decade. To ensure the continued growth of our economy, we must work together to attract, train, and place new STEM graduates. We're addressing this challenge on multiple fronts. First, we've partnered with the state's community and technical colleges to ensure that students can begin their education close to home, be confident that their courses will transfer, and then complete their degrees at one of the 5 WSU campuses around the state. Second, we're really focused on maximizing retention and graduation rates of a very diverse population of students. Using evidence-based practices, we've created supportive communities of learning that have seen first-year retention rates average more than 97% over the past 4 years, including during the pandemic, which was a really crazy time for us. And finally, we've partnered with industry to ensure that what we teach and how we teach it ensures that our graduates are work-ready day one. Funding from NASA, other agencies, and industry propels our research forward. We've learned how to build better rockets, ensure cybersecurity of electronic communications, develop strong yet lightweight composites, and advanced technologies to address climate change while simultaneously training the workforce of tomorrow. We're excited to continue to partner in this space and really look forward to today's conversations. Thank you.
Thank you very much, Dean Rizak. And we'll close out with this portion with instructor Karine Morales-Vincent from Snow Isle Tech.
Thank you very much. Thank you. I appreciate being here. I'm a little bit nervous to be sitting with all of these amazing, wonderful people that are ushering the next generation into the realm of space. We are all excited about this, especially my students. I teach at Snow Isle Tech Skills Center right across the street from the Boeing plant in Everett. We start our students with exposure at the age of 13 once they leave middle school and start coming into the high school realm. We have our students for 2.5 hours each day, 2 different groups, exposing them to various courses of industry and pathways. We try to inundate them with the possibilities of our imaginations. We do not put caps on answers. Everything that they learn in aviation is related to everything else that they're going to see in aerospace. The wonderful thing about this field and the level that I teach at on the high school level is that we are opening up a world where they can make a wonderful living just by seizing their opportunities, meeting people, wanting to come in, learn the subject matter, but that is only half of it. We want to be able to turn out good people, people that have compassion and empathy and want to make a real difference in this world. And I am so incredibly respectful of the industry that has embraced all of us and are making a path for students that are barely out of high school. And I appreciate all of you being here and shedding light on how we can make a difference to students who don't know exactly where they want to be. As a teenager, I never thought that this was a possibility. And if we're going to learn something, we're going to learn it from each other. So if we keep learning and we keep speaking to each other, more and more students at an earlier age will be involved in this very lucrative, not to mention sci-fi kind of future that we are embarking on. I do appreciate you having me here. Thank you very much for all of you, and I appreciate it.
I didn't see a hint of nervousness, so thank you for that. All right, moving on from our education groups who have really told us about creating new technologies and creating work-ready students, day one work-ready students, I'd like to hand it over to Nikki Malcolm, CEO and Executive Director of the Pacific Northwest Aerospace Alliance, which represents a lot of our supply chain in the state.
Yes, thank you so much. And thank you, Senator Cantwell and Administrator Nelson, for the opportunity to come and represent the manufacturing ecosystem here today. We see it as our responsibility to support the growth and global competitiveness of the aerospace region. And what that means for us in the context of space is ensuring that we're supporting the manufacturing ecosystem to stay up to speed with what all of these amazing companies are creating and have the production capacity and capabilities that you need to help you move forward and help you grow as companies. And so the way that we do that, for over 23 years, we've been doing that and supporting through events and education. But we were able recently, through an award through the state 2 years ago, to deepen our initiatives and those commitments. And I'll speak specifically on the workforce and supply chain initiatives that we have through the Innovation Cluster Accelerator program that we're doing. We are going to be working to put out a website that really connects, called Aerospace Connect, to connect all of the different roles that are available in the industry. Myself, I came into the industry at a very young age and had no idea what the opportunities were, and we intend to make that very clear to anybody that wants to pursue a career in the aerospace industry. And at the same time, we want to work with the aerospace supply chain to improve their modernization of their manufacturing facilities, to make sure that we have the capacity to improve those, not only from that, but also to attract the next generation and ensure that we have the right types of technologies in to do that and to support these companies in their growth.
Thank you very much. And thank you to our panel. So I have a series of questions ready to go, but I would like to pause for a second to see if either Administrator Nelson or Senator Cantwell would like to ask something.
Well, I want to present a photograph that has meaning to Maria and to Bob and to the mayor. And I'll give this to you later, but basically, this is the Orion spacecraft taking a selfie photograph of itself at its farthest position from Earth. And in this selfie, in the background, is the moon, 40,000 miles away from the spacecraft. And then the Earth in the distance, the blue marble, 270,000 miles away. It's the farthest that a human-rated spacecraft has been. And so I've signed one of these photographs for each of the three of you, and I want you to have it.
Well, that is absolutely breathtaking. Senator, is there something you wanted to?
I don't want to steal your thunder since
You
might
pay
have
my
a-
bill, Senator. Have as much of my thunder as you would like.
Hi. Well, we had a tour earlier, and it was great to see some of the challenges that Blue Origin is meeting. But one of the things that struck me when you were looking at the composite material that is being made is, I mean, today really is about what is it that we need to do to stay competitive so that Administrator Nelson is successful at having the United States lead in space. And I was struck by something that you said, Bob, that you thought it was literally in the manufacturing rate of composites, that the science part was not the hard part was the manufacturing rate of composites, which is exactly what we've been thinking about in aerospace overall, that it's the same issue of if you're going to have a transformation in the next generation of planes, and how do you produce high rate of composites? So what is that problem really about, and how do we solve it, and how could a manufacturing institute, how could that help that?
Well, I think that is one of the things that the aerospace industry as a whole undervalues, that manufacturing is the hard problem. We tend to focus on, I've been an aerospace professional my entire career, things going hard and fast, and wow, isn't that some great technology? But unless you can produce it and produce it at rate, it's nowhere close as being valuable as that. So if you even think about what the aerospace industry, aircraft, spacecraft, even launch vehicles, the rate of production isn't very high. So we don't get rates of learning. We don't facilitize for those kinds of things. And I think one of the transformations I think this generation of space leadership is doing is saying, no, we have to figure out how to make automotive grade quality, because the aerospace quality rate is nowhere close to that. We inspect in quality. That's how we make sure it's safe. But we need to make sure that we can design it in, and we can produce it at rate, we can produce it in large scales. And I think one of the things that we need just in Washington State and across the country is focus on that manufacturing technology and focus on those investments, because that's one of the places that I think we in competitives around the world has actually lost a step. And I think the more that we can invest in the technologies, manufacturing technologies, and the skills that go behind that, and then incentivize really from regulatory and tax policy, environmental, et cetera, people investing in the facilities here in the United States, here in Washington State, the more we can do that, the more we're going to actually blow everybody else away on the planet.
So Dean Rezak, do you have a response to that? And am I correct that the fact that the mission now defined by NASA, that we're not going back once, this isn't a one-time thing, this is about exploration for the future, has then increased the demand for this high rate of manufacturing? Is that right?
That's exactly right. I mean, making things reusable, making things sustainable is that. I mean, it's like, fundamentally, if you actually talk about what happened with Apollo, you built up this incredible manufacturing and workforce space, and then it kind of went away. And some of it transitioned into the shuttle program, but it didn't sustain because we went to different systems, toolings, et cetera. And so there's a lot of lessons to be doing about how do we actually do this consistently and do it at rate so we can produce a number of other systems that we can build off of.
Yeah, no, I appreciate the opportunity to speak that out, and I would just say that my perspective is very, very similar to Mr. Smith's, that in order to reduce costs, one has to have some consistency in design. There has to be adaptability from one system to another, and you have to do it repetitively, right? So space to this point has really been one at a time, very focused, and if we want to take our engineering learning and reapply it, we have to look at the reusables, the recoverables, the continue to adapt and adjust, but an absolute continued focused on quality and safety, right? So we have to do all of those things at the same time. But if you look retrospectively at other great engineering achievements, that's happened, right? It happened in automobiles, it happened in communications, it's happened in really every segment that currently is operating at a low cost. But in order to maintain those continued advancements, I think you need both a workforce to help you do it, which I care a lot about, but you also need a continued market, right? There has to be a demand for this product continued over time. And at this point, in really all of those sectors, there was significant federal support for ensuring that those sectors move forward. And continued support over time is, I think, going to be critical to seeing these things happen.
I'd like to continue on that theme of continued federal support. I think, Bob, you said something that I really like, that good government enables great companies. So I'd love to hear from maybe Stoke or Gravitics about what other actions you would want the government to be taking in order to enable companies like yours, and your growth here in Washington, of course.
Yeah, so first of all, Washington has been a great place to set up shop. We did that consciously. Washington has a incredible nexus of established engineering talent, of industrial base, and then for us, very importantly, is the software side, and I think there's no city in the world that's better suited for software development. So all three things come together here in Washington State, and that's why we decided to set up shop here. Maybe I can chime in also on the manufacturing side. I think one thing that I would comment on is in aerospace and space vehicles, we've been stuck in this world where we're manufacturing rate limited, where we build one-off bespoke vehicles that then typically get thrown away. And because of that, in order to get reliability up, we put a whole lot of effort into verification and certification, and it's a huge amount of the cost. Reusability breaks that cycle. The second thing, and the thing that's related to manufacturing, is the idea of being able to iterate. It is very hard when you're building something like 10 vehicles in the Apollo program, 20 vehicles. It is very hard to get in a place where you can capitalize and get efficient production. And then the idea of iterating says, okay, now you have to go throw all that away and recapitalize. To Bob's point, when you look at automotive-grade manufacturing, the reason they're able to do that is they make massive investments into production lines that pump out hundreds of thousands of units, and every 3 to 5 years, they can afford to recapitalize. That doesn't exist in aerospace. So my point is, in manufacturing, it has to be a very conscious decision how you do the design from day one in order to iterate. If you look at automobiles, I think, personally, there's no modern marvel more incredible than a car, a modern day car. The fact, if you look at the technology that's packed into that you can buy for $20,000, $30,000, $40,000, it's unbelievable. And the reason is it iterates at 3 to 5 year cycles. So how do you do that for aerospace? You do that by investing and designing intelligently for manufacturing so you can build quickly, right?
Thank you. Want to turn to maybe some of our educators. The statement was made about there are 1,000 jobs that have to be filled, and there's just such a need to get more students involved and interested. So I'm wondering if some of our educators on the panel can talk about what more we can do as government, what more as companies can do in order to increase those pathways for students to come into the sector. How about, yeah, you looked like you wanted to go, Corinne, I could tell.
Thank you. So at a place like Snow Isle where I teach, we enable them to believe, and we give them the proof that they can go out into industry, have a living wage, and we can stop calling back our retirees. A lot of the people that I have worked with in the past have come back to the companies that they have retired from because of this lack and shortage of workers for the aviation and aerospace industry. When the students leave the high school, whether they go into college or they go into industry, I always advise them to befriend the oldest, the most senior, the people that are actually going to contribute positively to their lives industrially, so that that generation can go ahead and stay retired. We try to get to 67, 70 years old, and we're so happy to be retired. I know at least 24 that have retired on Friday and go back to work on Monday. Gratefully, we do have those people who will say yes to get us through. But we have to push these younger people into the realm of having the possibilities to hold these jobs where they can make a living wage as early as their 18th birthday. Many students don't know that that's an option for them. And COVID has taught us that a lot of our students have stepped up to be caregivers and actually bringing home a fair wage so they can help support their siblings and their parents. So information for these younger students is key. And we need to bring you guys into our schools to let them know this can be done. We do want you. Don't think about it. If you want to go into industry, there are people who are going to help you.
Thank you. So I believe we're about to shift into some audience questions. As that gets underway, maybe I'll direct one more question out there to Nikki. You represent both sides of the aerospace sector. I'm wondering if you can talk about what you're seeing, maybe the driving technologies of the future. What can we start inventing here?
And Richard Dwayne.
Oh, sorry.
And Richard Dwayne, if I could just add, and Nikki, so if the notion here is that space manufacturing is here, how does that help airplane manufacturing? And what do we do to keep the synergy between them going?
That's such a great question. And Bob, I love what you said about manufacturing and enabling it. And so there's so many similarities between traditional commercial aviation manufacturing and space. The first being quality, right? There's no question on whether it has to be the highest quality thing out there. So there's a lot of crossover in what we do and how they help. And I think that I use aerospace interchangeably, and I know some people like them to be separated, but I use it interchangeably because I think that there's such an amazing collaboration opportunity between the two because we're making the same kind of parts. And quite frankly, a lot of times the machines don't care whether you're making space parts or commercial parts. So the collaboration both on propulsion sides and how we use energy, I think that there's a lot of opportunity to create synergies between the two of those because a lot, especially in composites manufacturing, utilizes a significant amount of power in autoclaves and things. So I think that if we found ways to collaborate even closer together, we'd find some of these automation things when you're looking at how chips, I was recently in it out-of-the-box manufacturing and looking at how they utilize automation to make things quickly, like the automotive facilities, and trying to think like, how do we bring that to aerospace manufacturing into this high-mix, low-volume space? How can we create automation from a place that doesn't benefit from the high iteration of automotive? And I think that we have the brain capacity in this room alone to find ways to do that. And that significantly benefits both commercial aviation and space.
All right, are we ready with the first audience question? I have more, so we can always keep going. Oh, fantastic, all right. Do we have a mic? Oh. All right, hold on. Oh, you got it, all right. Yeah, just let us know your name and go ahead, please.
Hi, I'm Lena, and my question is, what are your plans to help kids in middle school get more interested in STEAM and space?
Who wants to take it?
If you want to get kids interested in space, I can tell you one way NASA does. We have an astronaut in a blue flight suit walk into the classroom. And you ought to see how their eyes light up. There is a fascination about space flight from the American people, but that's particularly so with children. And we saw, for example, the educational benefits that came out of the first time we went to the moon. For a couple of educational generations thereafter, we had new generations of engineers and technicians and mathematicians and scientists. And so too, now with the Artemis generation, I think we're going to see a similar occurrence. As a matter of fact, NASA has a comic book, and it's geared to the grade level, and it's about a young woman who goes to the moon. It's just another means of trying to communicate. And so as we go back to the moon, watch what happens to getting students interested again all the more in the STEM, and we now change that to STEAM with the additional A being the arts. Look at the surge in numbers that you will see in the schools.
I guess I would add one, did I get this? I guess I'd add one thing to this, which is that representation matters, and I mean that in the broadest sense, that people, when we do Club for the Future events, it's so important that people that haven't been to college go, no, 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 you can be in the space program. And they don't really grasp that. You know, people that are in underrepresented communities, same thing. No, you can be part of that. So we spend a lot of time not only making sure that people, it's not hard, I don't think, to get people excited about space. It's almost natural that people get excited about space. They generally want to go do this. People like to explore. People like to do hard things. But seeing that they're part of that future is really important. So the more we can do that, I think it's incredibly important.
So you don't have to be a rocket scientist to work on rockets?
No, I mean, space lawyers. We didn't have them several years ago. We now have lots of space lawyers, which is a good thing. No, they're actually good. We have some great space lawyers in the audience today.
I want to tell you about the classic story, and this is a true story. It's been magnified a little bit over the years, but half century ago when we're getting ready to go to the moon, and of course it was a space race then with the Soviet Union, reporters covering the space program down at the Kennedy Space Center walked over to an employee who was cleaning out a ditch. And they said, tell us, how would you describe what you're doing here in the space program? He's digging a ditch, cleaning it out. And he says, I'm helping to put a man on the moon. That's the kind of ethos that we have. So we learned over there at the community college, in 12 weeks, they can produce a technician, 12 weeks of school, and they can get a job related to that technology that they've just learned. That's a part of our space program.
I saw a couple other hands go up, so Dean Rezak.
Yeah, thanks, Richard Dwayne. Lena, I think you probably have asked the most important question of the day, because from my experience in terms of recruiting students into the college, into engineering and computer science field, students have already made a decision about what they're going to do at the middle school levels. And so we can reach you occasionally, but it's hard. And I think it's got to be a community effort. I absolutely agree that if we are going to be successful in space, we will be the most successful if we have all the voices at the table contributing to that conversation. So at the university, we're super proud of the fact that we have a really diverse population of students that we work with. More than a third of our students are the first in their family to go to college. More than a quarter come from socioeconomically disadvantaged families. We've got a third of our students who identify as a race other than white, and a quarter that are women, individuals that are not historically represented. And so we're super proud of that. But we also know we're missing a lot, right? We're missing kids like you who made a decision in 5th or 6th grade that sent you on a different path. And I actually think as we move forward, your question is the most important question. I don't have an answer to it, right? We do lots of little stuff around the edges. We've got the biggest student club on WSU's campus. It's called Cougs in Space. It's got hundreds of students. Blue Origin has been a great partner for us in that. They build satellites and send them into space on NASA rockets. So it's all kinds of cool stuff, but it doesn't necessarily get to answering your question. And I think finding a way for us collaboratively, federal government, state government, industry, academic institutions to work more aggressively to help grade schoolers and middle schoolers understand the opportunities that are available to you, I think it'll help us all. So, great question.
Thank you. And I would like to give a minute to Dean Yang and then to Instructor Vincent as well to answer this question about inspiring more middle schoolers into the space fields.
Thank you. Thank you for the opportunity. At University of Washington, we have something called Discovery Days. We're actually using this off year to reimagine what will the Discovery Day look like in the future. So what they are is we actually allocated 2 entire days for middle school and high school students from the region, not only Seattle, but across Washington State, to come to our campus. We have exhibition booths to show you the robots that we use for high-rate manufacturing, how we use data or data visualization to help improve manufacturing, and also how do we recycle fibers from a sustainability or environmental point of view. So there's lots of engineering showcases. I strongly encourage you to come to our Discovery Days. And also we have many, many student groups who regularly visit our K-12 schools in the region. And I'll make sure that if you tell me which school you are, I'll make sure our students visit your school. Thank you.
Instructor Vincent?
One of the things that I really like about where I work, I like so many things about where I work, is that starting in 8th grade, the students are allowed every summer to come and take one of our many programs. And of course, I'm doing the aerospace manufacturing, but we have engineering. We also have advanced manufacturing. And they can get half a credit per summer for the 4 years that they will be attending high school. So that gives them a little bit of an understanding of at least 4 different programs out of the 24 amazing programs that we do offer. So exposing them at 13, 14, 15, all the way up until they're able to come to us in junior year is a very important part of spreading the word on what we do, what we have available, what they can earn, and what are the benefits from going to a school such as a tech school, skills center. We need to stop thinking negatively about tech schools and start thinking that only special people decide to go into schools because they want to start their careers earlier than a 4-year college. And we're exposing them to industries that will actually help them attain those goals if that is their wish. So like I said, in our school, we give them the way to come and spend the summers with us, to be exposed, and eventually join one of our classes so we can put more people into the space and aerospace fields.
Thank you. Why don't we take another question from the audience? I think we might have somebody lined up.
Hi, thanks. My name's Tommy Gantz. I'm with TLG Aerospace. We're an aerospace engineering firm and a Blue Origin supplier. I just want to thank you, Bob, for your comments about including people of all technical backgrounds into the industry. I was a late in life bloomer, and so something that's been very important to me is I work for a really, really incredible engineering firm. I'm not an engineer. There are so many people that have the ability, they just need upskilling. So for me, I think it would be great to see more investment in job skills training programs so that you can get kids in the door at entry-level programs and then upskill them to your engineering roles. So thank you.
What was your original degree?
Actually, I had a liberal arts degree as an undergrad, like a 2-year degree, and then I was a single mom, so I went back to school at University of Phoenix, got a degree in business. So nothing as impressive as most of the people in this room, but I've got just a cool
Well,
job.
I got a liberal arts degree and ended up working in software. And I used to say all the time that my brother, who, he used to wire his bedroom so if I went in it, when he was gone, an alarm would go off. And I kept thinking, he's the engineer, right? But what you find is that these companies have many different types of jobs, and they can be marketing, they can be communications or lawyering. But I do think one of the things, Administrator Nelson, that we should bug our Commerce Secretary about, because she was very good at this as governor of Rhode Island, which was to take the sectorial shortages that occurred in their state and match them with a program to quickly repopulate the skill set. So I think in addition to what the two deans have said, I think upskilling, a program that would just to be upskilling of people who would be willing to join the space sector, because if we communicated to them, such as yourself, these are the jobs. Administrator Nelson, I was just down at Cape Canaveral, and it was a Sunday, and saw a worker there, and so I said, "What's your background?" And she said, "I just got out of the Navy." And what was so interesting is that she said her father and her grandfather had worked, this is at Lockheed Martin. And I thought, but yet still, even though both her father and grandfather had worked there at Cape Canaveral, probably, I didn't ask specifically if at Lockheed Martin, but she still went to the Navy. She didn't have an opportunity to go get this degree, but I think there are a lot of pathways to work on space. I think that's what we have to shout out to everybody. There's a lot of jobs here. It's been a big booming economy here in the Northwest, but we really are, as a nation, trying to compete in space. There is a lot at risk here and a lot of opportunity and upside. So we just need to call on Washingtonians to help us upskill from where they are and help fill these jobs so that the United States can be competitive and we can reach this mission.
By the way, I was the only lawyer to have flown in space, and NASA chose not to publicize that fact.
Maybe just to hammer that point home, I think if you look around at all of the displays here, they are beautifully designed graphics. Those are not done by engineers. Those are just done by artists, right? If you look at the inside of the Blue Origin capsule, also not done by engineers, right? So there's just a ton of different disciplines that maybe are not what you think of traditionally as aerospace and tech that we still need as an industry to move forward. So regardless of your passion, regardless of what you want to do, there's a job in aerospace for that thing. I also want to hammer home the need for technical talent, and I think from a policy perspective, and the incentives are very good, but I think there's also a PR element to it that needs to occur. I think the point was made that maybe there's some stigma associated with technical jobs. I know in my generation, you think about high-paying jobs, college is effectively the only option, and that's simply not true. There's so many high-skilled, high-paying jobs required for us to do what we want to do, especially if we want to keep it on our shores, that there's a huge gap that's forming. I think it's incumbent also on our companies, and Blue Origin's very good and proactive about doing this. We've tried to do something, even though we're very, very young, to try to foster those skills in a entry-level aerospace technician program, where we're already bringing people with only high school diplomas or not even, and trying to train them up in order to move in and upskill kind of on the job in order to fill those really high-paying technical jobs. It's a big gap, and we collectively need to figure out a good solution for that.
If I could, I am very passionate about this. I started in the industry when I was 18 as a filing clerk. And so my career has been an example of the fact that I had no formal education coming into this industry, and I've gone on to have an incredible career. So I'm very passionate about making sure that other people have access to those same opportunities and understanding that those opportunities exist. And oftentimes in the industry, we get people who their mom or their dad or somebody in their family worked in the industry, and that's the only reason they knew anything about it. And so my firm belief is that we need a Got Milk campaign for the aerospace and space industry. That is a space that we can all collaborate on to speak from one voice, to say, this is an incredible industry. Come join us. Come help us get off, go to space. Come help us with the green technology. Come help us solve these problems that we have and attract that next generation of people with one voice.
That's really great. Thank you. I think we've got another audience question.
Hi, I'm Zataya Mitchell. I'm from Snow Owl Tech. And I was wondering, how are you going to make sure that genders, like women, are going to continue to thrive through this industry?
We take diversity very seriously. Joe Biden takes diversity very seriously, and therefore it's not just NASA, it's throughout the federal government. I took it very seriously in the 18 years that I was in the Senate. As a matter of fact, our deputy administrator is an astronaut commander, the second woman to be a commander. She also was an Air Force test pilot. Look at our crew that's going to the moon. They look like America. The 3 Americans, 2 F-18 pilots, one, the commander, white male, the pilot, African American, and the engineer, a woman. And you will continue to see this. So too the way that we are reaching out with our grants across the country and our interns. For example, we want to make sure that we get grants into the rural parts of the country so that they're not cut out of space research dollars, in addition to the gender as you have directed your question. So we take it very seriously.
I would just add that we, in the CHIPS and Science Act, the National Science Foundation did an analysis of this. Actually, the University of Washington did the analysis for the National Science Foundation, and it basically said you have to have women engineering professors. And when the University of Washington did that, it significantly increased the number of engineers. So they see people that look like them. It almost destigmatizes to a certain degree what that's about, and encourages more women. So now in CHIPS and Science Act, we have resources to go to universities to help them diversify their engineering workforce to get more representatives in engineering.
Thank you. Oh, sorry.
No, the last thing I'd add is that it has to be a priority. I mean, you just have to make it something that you want. There's a lot of good reasons why you want a diverse workforce, gender being in that, which is, I mean, I can make a good moral case, I can make a good societal case of why you want that, but fundamentally, when you're trying to build something really, really hard, you want the best people in the world to come work for your company. It's that simple. If you're excluding some percentage, half of society, greater than half society, that's crazy, right? So you have to go work on it because it's a business imperative. It becomes something that you absolutely need people to come work to your company. They're the best in the world, come work for your company because that's just good business for you. And we take it seriously, and it shows in actually who we actually even fly. We've flown 5% of the world's population in terms of people going to space. 9% of all women that have all gone to space have gone on New Shepard. So that's something we make a priority. Those capsules are curated for that reason.
My daughter is Lena's age, and she knew what Max Q was probably before she did her first lemonade stand.
I'm sure most people know what Max Q is, but there's someone in the audience who does not.
She loves aerospace, and yet still she asked me, "Dad, can I be an astronaut?" And that just like, oh my goodness, a knife to the heart. they need to see people like them in roles like they want. And every time we break a barrier, that's one more little girl like mine that says, well, of course I can. And we have so many more places we have to do that.
Thanks. I believe we've got another audience question.
Thanks. Over here. Tim Kirk from Torrey Composites. Thank you, Bob, again for hosting. The question's really for the senator. There was a lot of talk about composite manufacturing, and there was a realization at the federal level under the Department of Commerce in the 1990s that there was this huge advance in composite technology, but it was at OEMs, research universities, and national labs. And the Department of Commerce actually set up a technology transfer program to move that out to small to medium-sized companies. I think given the post-pandemic kind of restructuring that we've seen in the supply base, those small to medium-sized companies are now at a different part of the supply chain, or they're participating in different industries and may not be aligned specifically on the technologies, not just for space, but for high-rate composite aircraft manufacturing and other national programs. So is there any discussion, or what are your comments at the policy level for the federal government to maybe retool that technology transfer thought process and apply it to those small to medium-sized companies today? Thanks.
Well, I got interested in this, what you're asking, and maybe all of this, because at the same time, we were trying to pass this CHIPS and Science Act, which was really about how do we as a nation translate science faster. If you will, universities were being rewarded for basically publishing, right? If you want to get tenure, go publish. But in an information age, everybody was reading our publishing and then going and implementing it faster than we could. So we wanted to say, wait, we have to translate science faster and implement it if we want to be competitive. So at the same time, we were doing CHIPS and Science, then I heard this example over at Gonzaga University where they had gotten an NSF grant, an atomic force microscope, to look at impurities in composites. And it was helping the supply chain in that sector from Spokane to Coeur d'Alene produce better product. And I started hearing from the supply chain that there were people that were trying to buy them, European companies trying to buy US companies, because they were further ahead in thermoplastics than we were. And I kept thinking, well, wait, this is what we do here. Like, this is us. Why is it? So right in the same time I was called on to do this big task, I saw an example of it in our own state. Wait, if we're not translating the science faster, some other country is going to translate this science faster, and they're going to implement this, and it could erode our manufacturing base here in the United States. So I became a big believer in trying to solve this problem. I think, I'm happy to hear anybody else's idea here about this, but I think it's this manufacturing institute, because it solves both this problem that we have at NASA, and they're trying to take space into the manufacturing realm, and so they have to think about it. And we are now in space getting out of the big autoclave and now getting into thermoplastics. But do we know enough about it? Does our supply chain know enough about it? Do we have the R&D right? Are we figuring this out? I don't know. I'm basically just calling on us, hoping. Now, our best advocate is sitting right next to me, because he gets and understands this. The one headline I guess I would say for people is, people don't understand how much NASA drives aviation R&D. They are aviation R&D. Every investment that we make as a nation at how to stay ahead in aviation comes from NASA. So I asked him to come here to see all this so that he could help us figure this out. I think it's a manufacturing institute, that we do both, that we figure this out so that we as a nation, to serve this space mission, figure this out, and to stay competitive in aviation, figure this out. But I do think it's a collaborative between universities, community colleges and the manufacturers, I think. That's my sense. So I don't know, Bill, if you want to, Administrator Nelson, want to comment on that?
See, I told you Maria tells me what to do. Indeed. You think back to the changes that has happened in the history of the world. Because of the advent of technology, because of the cost of labor, so many legacy industries have been uprooted in the history of our country. And they've gone overseas. Well, what's the way to get and keep good paying jobs? And a lot of it is in the subject matter of which we have been discussing today. High technology jobs. It also happens to be a matter of national security. Why do we want to bring a chips industry back to our country? For obvious reasons. Why do we try to, through research, develop new ways of doing things and new products that will help us to enable ourselves to be more productive for our daily lives? Why do we do research in space on board the International Space Station in order to have better pharmaceutical products here on Earth? Why do we use our assets in space to look at Earth and to measure what is happening to the Earth so we can understand the changes that are going on in our climate in order for us to be able to save our planet? The use of technology. Applying new things in order to do things new, but to have a salutary effect at the end of the day.
Thank you, Administrator. So we are just about at time. I know Austin wants to jump in a little bit to talk about this competition, and then we'll see if Senator Cantwell wants to close out. All right, go ahead, Austin.
Thanks, Richard Dwayne. I wanted to just add in, as we think about, boy, how do we build American jobs, Washington jobs in the space industry? I think a key part of that is training and developing a workforce to fulfill those jobs. I think also a key part is maintaining U.S. leadership in the industry and making sure that we're the ones innovating and pushing forward what's capable. And so as we reach future iterations of what the space industry look like, it's companies in the U.S. that are leading the way. And I think that's something that sits a lot on our mind as we think about in-space assembly and manufacturing at Starfish and interacting with satellites on orbit. You've seen places like Japan or the UK or the European Space Agency put a lot of dollars and programs into supporting the development of these activities because they see the value of where they go long term. And I think that's an important thing for the U.S. to think about also, that as we're at the nascent stage of what's really going to be a rapidly expanding space industry here in the U.S., we need to make sure that we don't take for granted that we're on the leading edge of the curve from a technology standpoint. We need to make sure that we're pushing forward and innovating and supporting, in particular in the Seattle area here, we've kind of come together organically. We don't have a NASA center or we don't have a major Air Force base. We just have a lot of really capable, really passionate, really energetic people who are pushing forward what we can do as a nation in space. And I think we should make sure to continue to develop and grow that.
Well,
Richard
thank
Dwayne,
you.
Can I add just one maybe uniquely startup perspective to this? And that is that you talked about foreign investment into our industry, keeping those capabilities sovereign and on U.S. soil. One thing that I would point out is, as a startup, we've again raised over $100 million, and 95% of that is domestic. So I'm proud of that, but it's not easy, and there are a lot of foreign investors who would love stakes in companies like ours. And particularly in this environment where investment dollars start to tighten up, this is a place where we as a government can be proactive so we don't need to get to the point where a CHIPS Act is required to pull those things back on our soil. It's an opportunity where we can get ahead and keep investing in the core technologies that are very important for our civil missions, but even more important is for our national security in space.
Well, I can't really think of a better way to end a panel than with the words, making sure the United States is leading the way and making sure that we can build here in America. I think those two things are choices, and I thank every member of our panel and the people who joined us today for making that choice over and over again. So with that, I ask you to applaud our panel. Thank you for their time. I thank you for joining us. And members of the media, we will meet you for a press gaggle in, I think, about 5 minutes in the back. Thank you so much, everyone.